Good morning, student. In the previous class, we have seen the composition of function, inverse of function, and some questions based on these topics, and some questions of your Ncrt book. Now, students, today we discuss about the binary operation. Okay, students. So we discussed about binary operation. So what is binary operation? So students, let S be a known empty set, then a function then a function f from S cross S tends to S is called binary operation on set S. Okay, students, so from the definition of binary operation, we are seeing that let S be a non-empty set, then a function f from S cross S tends to S is called binary operation. So it proves that a binary operation is also a function from S cross S tends to S. Okay. Here we can say that a binary operation on a set as associate each element AB belong to S cross S. Each, here we can say that order pair. Each order pair AB belong to S cross S to a unique element FAB in S. Okay, students, a binary operation on a set S associate each order pair AB, because this domain is our in the form of Cartesian product. So we take AB belong to S cross S to a unique element F AB in S. Okay, and students, binary operation is generally denoted by a star, so either this, etc. Okay, so this is generally denoted by plus is also star, O, plus, etc. Okay. Now, students, we see that addition and multiplication are binary operation on set of natural number. Okay, students, plus and dot are binary operation on a set of natural number, because sum and product of two natural number is also a natural number. That's why. Okay. Addition and multiplication are also binary operation on set of integer, set of rational number, and set of real number and complex number. Okay, so plus and multiplication, addition and multiplication are also binary operation on set of integer, rational number, real number and complex number. Plus and multiplication are binary operation on set of natural number also. Okay, students, so this is some basic information about binary operation. Okay, so binary operation is a function from s cross s tends to s is called binary operation, and it is noted generally noted by this star plus o, okay, etc. Okay, students. Now, student, we see the number of binary operation. Okay, the number of binary operation. So, student, if a set has containing an element, okay, then s cross s have let a set containing an element, then s cross s has n square element. Okay, students, then this s cross s has n square element. So total number of binary operation, on set S is equal to n to the power n square. Okay, n to the power n square, because student, it is the relation of function from s cross s tends to s. So here is n square element and here n. So students, you know total number of function is what? N to the power n square from here, because we know that if a set A have m element and B have n element, then total number of function is n to the power m, and function is from A tends to B. Similarly here, we are seeing that n is square element and here n, so total number of binary operation will be n to the power n square. Okay. So now, student, we see what is about the types of binary operation. Okay. So type of binary operation, now we see. Types of binary operation. Okay, students, so first is commutative. Okay, so students, a binary operation star on a set S, a binary operation star on a set S is said to be commutative binary operation if A star B is equal to B star A, where for all A, B belongs to S. Okay, students, what is a commutative binary operation? A binary operation is star on a set S is said to be commutative binary operation if A star B is equal to B star A for all A, B belongs to S. Okay. So student, this is commutative binary operation. Students, plus and multiplication of commutative binary operation. Okay, students, plus and multiplication of commutative binary operation on Z. Operation on Z. Okay. Now we see next, students, associative. Next is associative binary operation. Associative binary operation. Okay, students. So a binary operation star on is set as a binary operation star on a set as is said to be associative binary operation if A star B star C is equal to A star B star C for all A, B, C belong to S. Okay, students, for all A, B, C belong to S. Okay, students. So, student, plus and multiplication are also associative binary operation on Z, but subtraction is not binary operation. Subtraction is not associative binary operation also, and it is also not commutative binary operation. Okay, students. So this is associative binary operation. Now, students, so next topic is student identity element. So identity element. Okay. So student, let a star be a binary operation on a set as if there exists an element E belong to S such that A star E is equal to E star A for all A belongs to S. So students, if this condition holds, then this E is called identity element for binary operation star on S. Okay, students. So student, a binary operation, let a star be a binary operation on a set S if there exists an element E belongs to S such that A star E is equal to A and is equal to E star A for all A belongs to S. So student, then this E is called identity element for binary operation star on S. Okay. So students, and 0 is the identity element. 0 is identity element on set of integer. 0 is the identity element for addition on set of all integer. Okay students, so this we can say that this is our identity element. Okay, if we are taking any element A with that element and it gives always A, so that element is called identity element. Okay, so here is we are taking 0. Suppose that we are taking 0 plus 1, so it gives 1. That is, this is our A, this is A, so this 0 is called identity. Okay, so this is our identity. Now students, we see next. Next is inverse of an element. Okay. Last is inverse of an element. Okay. So student, let star be a binary operation on S and E be the identity element in S for the binary operation star on S, then an element A belong to S is called an invertible element if there exists an element B belong to S such that B operation A star B is equal to E is equal to B star A. Then this B is called an inverse of element A. Okay students, so what is inverse of an element students? If let star be a binary operation on S and E be the identity element in S for the binary operation binary operation star on S, then an element A belongs to S is called invertible element if there exists another element B which also belongs to S such that this A star B is equal to A is equal to B star A, then this B is called inverse of A. Okay students, if star be a binary operation on S, then an element A belong to S is said to be invertible element if there exists another element B belong to S such that A star B is equal to identity and this is equal to B star A, then this B is called inverse of A. Okay students, I hope you understand. Now students, we see some questions based on binary operation of your Ncrt. So let's see. So our first question is, check determine whether or not each of the definition is of a star given below, given a binary operation. In the event the star is not binary operation, give justification for this. So first is on Z plus define a star by A star B is equal to A minus B. Okay students, so our binary operation is defined by A star B is equal to A minus B. Now we have to check that this is binary operation or not. First then select if A is greater than B. So if A is greater than B, we are getting A minus B. This is positive. Okay. So it is binary operation, but if A is less than B, this implies A minus B is negative, so it is not binary operation. Okay friends, there are two cases. If A, so this is positive and this which is belong to, this is positive, that is greater than 0 and belongs to Z plus, so this is binary operation. But if A is less than B, this is negative, not belongs to Z plus, so this is not binary operation. So friends, we say that this is star is not binary operation. Okay. Now second part we are seeing on Z plus defined by Z plus defined by A star B is equal to AB. So students, for all A and B belongs to Z plus, we see that AB also belongs to Z plus. So star is binary operation on Z plus. If we are taking any two positive value, the multiplication as these two will be also we get positive value and it belongs to Z plus. Now its third part student. On R, A star B is equal to AB square. Okay students. So students, for all AB belong to R implies AB square belong to R. So it is binary operation on R. Okay, I hope you understand students. Now we see some other question. part is on Z plus A star B defined by mod A minus B. So student, A star B is defined by mod A minus B. Now let for R AB belongs to Z plus our A star B is always that is mod A minus B always greater than 0. So it is binary operation on Z plus. Okay, because if we are taking any two element AB of Z plus, we always get positive value due to the modular sign, and this is always get positive, so that's why it is binary operation on Z. Now fifth part on Z plus, find A star B by is equal to A. So students, for any A, B belongs to Z plus, A star B is equal to A always greater than 0. Okay? Because if we are taking A and B positive here, A gives, so this is always positive, so we say that it is binary operation on Z plus. So I hope you understand, students. In such type of question, just we have to check if we are taking any two element of that particular set Z plus, then when we apply on it on A star B, it gives also positive value. Okay, it means the A star B whole ended. So if AB belongs to this Z plus, then this A star B also belongs to B and Z plus. Then it will be binary operation. Okay. Now we see second question. For each binary operation star defined below, determine whether star is commutative or associative. First, on Z, define A star B is equal to A minus B. Okay. Now students, we have to check that this is commutative or not, associative or not. Okay. So first, okay students, for commutative students we have taken A star B, okay, is equal to B star A. We know for commutative this, so A star B we can write A minus B, and this is B star A, this we can write B minus A, and A minus B is not equal to B minus A, so our star is not commutative. Okay. Similarly for associative, A star B star C is equal to A star B star C. This we have to prove that, but we are seeing our A star B is A minus B and this is A star C, and here B minus C and A star B minus C, A minus B plus C, and here A minus B minus C, this is not equal to this, so star is not associative. Okay students, so because for the set of integer, this commutative and associative, and in case of the subtraction, they both not hold. Okay, I hope you understand students. So now we will see some other question in the next class. Thank you so much for today.